when you tell it to stop the video. Okay, it's filming. We're filming. So, is anyone actually absent? We're good. Okay, so today we're going to talk about the law of conservation of mass and the law of definite proportions and the large implications for the future chemistry that the discovery of those two things made. So first, let's review. Or 2 weeks ago, maybe, we learned about the law of conservation. Well, no, the first law of thermodynamics, which says,
energy cannot be created or destroyed, but can change form.
Okay, energy cannot be created or destroyed, but it can change forms. So today we're going to learn about the law of conservation of mass, which is essentially the same thing, that matter cannot be created or destroyed, but that every atom that exists, of course they didn't know at that time, but every atom that exists is going to continue to exist as that type of atom, so that the total mass in the universe is constant, except for, now we know that those two laws go together into one kind of unified theory, saying that all the matter plus energy in the universe is constant. We know that, of course, in the sun, what they're doing, the sun is producing energy from nuclear fusion. That means that two hydrogen nuclei are slamming together to form a helium. Teeny pieces, mass is destroyed, and huge amount of energy is liberated when that happens. So there's a conversion from mass to energy, but the net amount of matter plus energy is constant in the universe. In our class, since there's no destroying of any type of mass ever, we can say that the law of conservation of mass is a sure bet. Every single atom that exists in this room is going to exist at the end of the class, or we won't. That's kind of how I like to reword the law of conservation of mass. Not just that matter can't be created or destroyed, but that every atom that we have here is going to still, whether it undergoes chemical reaction, physical change like freezing or melting, no matter what we do to the atoms that we interact with as a chemist, they're still going to be exactly the same element, unchanged atom that they were. So we probably need to kind of get a few more definitions under our belt so we can really talk about that. So you need to know what an element is. So I hope you've all been diligently studying your periodic tables for the quiz that I'm going to give in a minute. And every thing that you see on the periodic table, do I have one? I hope. Yes, I do. So everything, well, mine's all marked up. Everything that you see on the periodic table is an element. I think this periodic table is short a couple that have been discovered, but when they manufacture these last few elements in the lab, they exist for like mini microseconds. It's not like you can hold it in your hand and study it for a couple hours and play with it. They actually decay into less massive elements pretty quickly. But those that we're going to use in class, these kind of metals, non-metals, transition metals, are the smallest pieces of stable matter that have the properties that they have. So everything that you find on the periodic table is an element. And we're also going to learn about compounds today. When two or more atoms come together, two or more types of atoms come together to form a new substance that's a compound. They are chemically bonded together in a compound. So you have two or more atoms, they form a chemical bond, which we'll talk about what that is more and more throughout the year. They form a chemical bond together, then you have a compound. So two or more elements chemically bonded together form a compound. We will just keep it to two different elements for a long time because that just keeps it simple for you guys to learn. And then we'll add in compounds with 3 and 4 elements. But anyhow, so we've got elements, just single things that you can find just the way they are on the periodic table. Compounds, combination of two or more of these elements that are chemically bonded together. I'm going to define also for you chemical reaction. You guys have seen lots of physical changes like melting and boiling and freezing, and those things they're not chemical reactions. We've done lots of chemistry this year, but not really any chemical reactions. We've only had physical changes, changes that don't involve rearranging chemical bonds. Today we'll actually rearrange some chemical bonds in the least exciting way ever that you can't really see happening much. No explosions, fireworks, no stuff like that. But it does illustrate a very important chemical principle. But when you rearrange chemical bonds, you're having a chemical reaction. And when you have compounds or elements and they have a chemical reaction, their bonds rearrange. If you have a compound, let's say this is a drain opener, this is what people call lye, L-Y-E, lye. It's sodium hydroxide. It's a very strong base, it's corrosive, it will turn the fat in your skin to soap, make you feel slimy. It's not good to spill on yourself. I'll use it today, you guys will use it several times this year. But lye is a compound, and if I wanted to decompose it into its elements, look at me, I remembered to turn on the air conditioning today. If I wanted to decompose the lye into its elements, well, here, did you guys do chemical formulas this week? Okay, we won't go there then. Then I would have to break it down into, since it's sodium hydroxide, I would have to break it down into sodium, oxygen, and hydrogen. So it's made up of 3 elements, sodium, oxygen, and hydrogen. I could break it down into those. It can be decomposed into its elements if I wanted to. If I took something, an element, do I have an element sitting around? Okay, my gold ring. Assuming that all that's in here is gold, and of course we know gold is pretty soft, and you have to kind of make a mixture of metals out of it to keep it from just being completely squishable. But let's say if my gold ring were completely gold, gold is something that you can find on the periodic table. Its chemical formula is AU. And if you find gold on the periodic table, AU right here, number 79, you know it's an element. So you can't break that down into any smaller pieces. An element just can't be broken down into smaller pieces. Gold atoms are the smallest piece of stuff that is gold. But compounds like sodium hydroxide, they can be broken down into sodium and oxygen and hydrogen by rearranging the chemical bonds that are present in that compound. So, the law of definite proportions is another really important discovery in chemistry. And essentially what the law of definite proportions says, does anyone want to read me the definition, which you need to know for the test? I'm pretty sure you actually have to regurgitate the law of definite proportions right onto the test, Lily.
The proportions of elements in any compound is always the same.
Okay, so what does that mean to you?
You're always going to have the same ratio, I guess is the word, of elements, one element to the other in each compound.
Yes. Yes. So I like to think of it in terms of recipe. So the law of definite proportions. To me, are we having filming trouble?
Would now be a bad time to tell you I can't read a lesson thing you just wrote on the board? I think it's because I zoomed in.
Oh, well, it won't focus.
It's just so funny. Can't read it.
Alright.